So today we're going to talk about how to calculate the LA-AO ratio, which is an important parameter that we look at when we assess the hemodynamic significance of the PDA. And of course, this is an important parameter as per the targeted neonatal echocardiography protocol. So just a little bit of physiology first. In the absence of any cardiac shunting, usually the blood will leave the left ventricle, representing the systemic blood flow. This blood is going to return back to the right side, and then it's going to leave the right ventricle towards the lungs, and then back to the left atrium here. Now, in case of the PDA, as you know, the PDA is going to cause pulmonary overcirculation, especially if it's hemodynamically significant. Here, the blood is going to leave the left ventricle, and this is the aortic valve here. Some of that blood that left the left ventricle is going to go through the PDA, joining the right ventricular output that will flow through the lung and then back to the left atrium. And then the more blood that returns back to the left atrium, it's going to cause dilation of the left atrium. So the point here is that the left atrium gets dilated. However, the aortic valve area is not going to change because it's technically fixed. This will make the LA-AO ratio goes higher, and the higher it is, the more consistent with pulmonary overcirculation. Now I'm going to show you how to calculate LA-AO ratio using the echocardiography. So this is a peristernal long axis view. As you see here, the right ventricle is on top, the left ventricle is at the bottom here with the intraventricular septum in between. The most posterior structure of the heart is the left atrium, which is here, and this is the aortic valve here. So the classical way is to run the M-mode cursor through the aortic root and then going through the LA. As you see here, this is the cursor going through the aortic root here and then the LA here. And this is the M-mode picture, and we can measure the LA dimension here, as you can see with this line, and then the aortic root diameter on the top here. And then we can come up with the LA-AO ratio. The problem with this method is that the LA, as you know, is a 3D structure. So the dilation is not always here at this level. It could be at this level here, or it could be at this level, or it could be at this level here actually, meaning that we're not going to catch it with the M-mode cursor. So it's better actually to look at the LA volume index, and I posted a video last week about how to calculate the LA volume index, and feel free to watch it. The other way to measure the LA-AO ratio, which is a little bit more accurate actually, is just to freeze this video here before the mitral valve opens, and then we measure the LA dimension on the 2D image here, and then we can simply measure the aortic root diameter at this level here. As you can see here, this is the LA dimension, and this is the aortic root diameter here, and then we come up with the LA-AO ratio. I hope this was useful, and see you in the next video.